First participant for today is Anuraj RAWAT from NUS, the National University of Singapore. And the topic is Breaking the Wall of Self-Powered Human Sensortronics.
Is the mic working? Okay, cool. Okay, so, are we ready? Okay. Imagine our world without our senses. Our heightened responses to external stimuli is what differentiates us from other living organisms. These senses are because of our highly developed systems of sensory organs. And amongst them, perhaps the most versatile is the human skin. Now, the human skin acts as a sensor which can simultaneously detect touch, light, as well as temperature. Now, given its multimodal sensing capability, there has been a large rise in the industry of wearable electronic sensors with applications in health monitoring, advanced robotics, as well as new age prosthetics. However, these sensors do have certain limitations. Firstly, sensors that are used in this industry are usually for uni-purpose, where they're only really able to detect to a high intensity one single sensing parameter. Secondly, they need to be powered by external sources, meaning that there is a lack of self-sufficiency, therefore making integration at the large scale very difficult. This is where our solution comes in. Essentially, what we've done is that we've tried to create a tactile sensor using the reverse electrowetting on dielectric effect to create high sensitivity of touch down to the fingertips. To improve our sensor functionality, we have drawn inspiration from nature, specifically photosynthetic proteins that carry out photosynthesis similar to plants. Now, when these proteins are integrated with our sensor devices, they add new functionality, specifically light. So when light falls on these proteins, what happens is electrons are excited, and there is a separation of electrical charge inducing a voltage. This induced voltage helps us to simultaneously detect light alongside with touch. The voltage that is induced can further be stored and used at a later time, showing promise for self-powered sensortronics. Furthermore, since we are dealing with protein here, in the future we can sort of introduce these proteins to different temperature conditions and see how the changes in their biological nature may be used to explore temperature sensing as well. Overall, this approach brings us one step closer to new age human sensortronics, which would make wearable sensors as well as prosthetics and robotics for the masses. Thank you very much. Are there any questions? Yeah, are there any questions?
You have like 12 seconds if you want to ask questions.
Have you given any thought to how you're actually going to store that power?
So at this point in time, we haven't, because our first aim was to try and generate the voltage, which was enough for us to be stored. So we managed to get up to 1.5 volts. We haven't gone to the next step of trying to store that energy and then harvest it and use it in our sensors again. So right now we haven't. Yeah. Thank you.
Okay, thank you.
Thank you.